At a two-dimensional example with not with what's it, planes, trains, and automobiles. We're focusing on the planes right now. So this is, I think, of one of the most typical examples that you could have. A pilot needs to, travel from A to B, which on the ground works out to 1,600 kilometers, 40 degrees north of west. So that's where the pilot has to go. This is the schedule, the flight schedule. Okay, that flight schedule will be sort of done weeks in advance. So you can't consider wind speeds when you're doing that. We do know that at the particular time of the flight, this is the wind speed at that particular altitude. Okay, so determine the required airspeed of the plane. So this is where does the plane, what I'm asking here is what does the pilot have to do? Where does the pilot aim, and how fast should they plan on flying in order to maintain this schedule? So the first thing that you do, the very first step, is take that distance that has to be traveled, or displacement, and divide it by the time to get the actual ground speed. So remember, VPG is ground speed. So there we are. We know the ground speed is 400 kilometers per hour, 40 degrees north of west, and we know the airspeed is 85 kilometers per hour east. And we need the VPA. Okay? VPA being airspeed. So ground speed is wind speed plus airspeed. Airspeed is the subtraction, and just in sort of variables, that's what it means. So you could do this math, because we're just adding vectors now, right? Or subtracting vectors, I guess. We're subtracting this, take away that. We could do that using the skills we learned. We can use x and y components. We can use sines and cosines. I almost always typically do cosines and sines. I think it's fewer steps. So here we go. If I want to find VPG, it's going to be this plus negative VAG, right, which is 85 kilometers per hour west. So I'm adding it, because the real thing I want to do is a subtraction, but I'm adding the west because I'm subtracting the east. Okay? So draw a picture. Here's my ground speed, and add on to it the negative airspeed. And this is my resultant, wind speed. And here's my resultant airspeed, P for VPA. Okay, and just to see if this makes sense. Okay, this is where the plane wants to go, right? The plane wants to end up here. That's the goal. Starting here, ending here. Imagine this, you're actually looking at the map, okay? Starts here, ends here. The wind speed is east, 85 east. So where this guy, girl, pilot aims is over here to get pushed right back to where the intended end goal is. Okay? And that's really what's going on. So you can look at this and see it's clearly an example of cosine law, sine law. So coming down to the cosine law, solve for P, 468 kilometers per hour. And the angle, let's look at the angle. We need to, what I'm going to say when we find the angle is we're going to find this one here, and then the P will be, this plus this degrees west of north. Okay? So solve for the angle, sine law, isolate theta, 6.7. So I rounded that to 7 down here. So the required airspeed then, just looking at this, it's there's 7 degrees in here, so it's going to be 57 degrees west of north. Okay? And let's just see, does that number make sense to us? The pilot has to go 400 kilometers this way, but the wind is pushing the pilot out of the way a bit, right? So you can see he has to go, or she has to go, a longer distance on an angle further to the west, so that the east wind will push the pilot back where they want it to be. Okay? So remember, if this was a vector addition, really what it is, to get the ground speed, which is the 400, you would add P plus 85 east, right? But we're doing the subtraction to find P. So the number makes sense, and that's relative velocity with airplanes.